Audible. Hello.
Sir, good evening, sir.
Voice is clear.
Not clear, sir. It's very low voice is coming.
Now it is clear.
It's okay, sir. It's okay now.
Okay, okay. So in today's session, I have taken some root locus based question and some Bode plot based questions and Nyquist plot also. Some Bode Gate 2024 question also I have taken. So we'll see questions one by one. Okay.
Today, this week, Nyquist criteria is covered more, sir.
Okay. Nyquist is there. Bode is also there. Both are there.
Okay, sir. Okay, okay.
Okay, okay. So what is there in this week? Like, okay, I will.
Nyquist,
So can
Nyquist, sir.
Nyquist is there. Okay. Any other doubt also
Actually,
you will have, you can ask me. Like if you are
okay,
facing
sir. Okay.
doubt in any
Nyquist
type
is
of question.
Bode one chapter is covered. Nyquist
Okay,
three
okay,
chapters.
okay, okay. So we'll discuss both. So some remaining root locus questions are there that are good question only. So
Okay,
I will solve those questions first. Then I will go
okay,
to the Bode then Nyquist. Okay. So what will be the correct option out of four? Uh, it's easy only. Can anyone of you tell? This is a valid root locus. First one. No, because this is not symmetrical with respect to horizontal axis, so this will not be a correct option. Okay. If you'll see this one, so here one pole, here one pole is there, here one zero, and here only one pole. Okay. So this also will not be correct. Why? Because if you'll see here, this side. So right hand side, odd number of polar zero are required, but here 1, 2, 3, 4 is there. Okay. So for this one, correct root locus should be like this. This one and one is there, and here on pole and zero. So it will start from pole and it will go towards zero. Okay, like that it will go. And a number of asymptotes will be how many? 3 minus 1. 3 pole minus 1 0. So how many? 2 will be there. So it will be like this. Somewhere breakaway point will be there and it will go like this. So this is not correct also. And if you see this one, this is looking correct because it is symmetrical with respect to x-axis. And this is also correct. Two pole here and one pole here. So it will tend towards infinity and it will also tend towards infinity. So this B and D are the correct option. Is it clear to all? Should I move to
okay,
the
sir.
next
Clear,
question?
sir.
Okay, okay.
Sir, explain about this C option, sir.
See, here if you see on the real axis also. So this is real axis. In right hand side, how many
Not
numbers
B,
of
not B, sir. C.
C? Okay, okay. C1, 1 second. So here one pole is there, one pole is there, one zero is there, one pole is there. If here two pole will be there, then it is correct, I think. If here two pole will be there, then it is correct. But here only one pole is there, so this is okay. Here one breakaway point will be there, but this it will start from pole and it will interest zero. But this side root locus should not be there because if you see in the right hand side, okay. So this section is there, right hand side four number of pole and zero is there, but it should be odd. So that's why this real axis should not be here. Okay, that's why it is incorrect. So if you draw the root locus, it will start from pole and it will go towards zero here. And here these two poles are there. Okay, so it will start from these two poles and it will meet at some break point. And after that, it will go like this based on the asymptotes. Okay, is it clear?
Okay, sir. Okay, sir. Clear, sir. Clear.
Okay, okay. So this is the next question. Here a transfer function is given, okay, and we have to calculate the. So it is saying that the root locus is a circle. We have to calculate the center of the circle and diameter of the circle. Okay. So I'm going to draw the root locus first. So one pole at minus one, and one at at plus one, and one at plus two. Okay, and one zero at minus five. So how it will be? It is showing it is a circle, so it will start from here, and then it will go like this. Okay, Circle means it will be like this only. It will go like this here, and it will come like this. Again, it here break-in point, so it will go towards 0, and 1 will go towards here. So this is a circle. We have to find the center of the circle and radius of the circle. Okay. So how we can find? If we'll find the breakaway point, if we know this point and this point, then we can calculate the diameter of the circle, and then radius and this point also we can calculate. So how we can calculate the break point? That d by ds s plus 5 divided by s square minus 3s plus 2. This should be equal to 0. Okay. So what will be the denominator? That will be this square, s square minus 3s plus 2s square. Again, numerator it will be s square minus 3s plus 2, and this differentiation will be 1 minus this differentiation will be 2s minus 3, correct? And it will be s plus 5. This should be equal to 0. Okay. So if we'll simplify this one, this will be equal to s square minus 3s plus 2 minus 2s square, this minus 2s into s, plus here it will be 3s. Again, minus 10s, okay, plus 15. Is it correct? So minus 3s and plus 3s will cancel this. What will be the value of s? Can anyone solve this? Is this calculation is correct up to now? So it will be minus s square. This s square and minus 2s. This will be minus s square. Again, it is here minus 10s plus 17 is equal to 0. Is it correct? All of you can solve this quadratic equation also. So whatever value of s we will get, that will be the breakaway and break-in point. Okay, from this equation. So I'm going to solve this equation. 1 second. Minus s square minus 10s plus 17. Minus 1 minus 10 and 17. 1 second. How much we are getting? Anyone got the value of s from here? So I have calculated. I am getting 1.48 is s value. Breakaway point s is equal to 1.48, and second one is minus 11.48. Is it correct?
Yes, sir.
Okay. So here it will be 1.48, and here it will be minus 11.48. So what will be the diameter of the circle? See, this root locus is a circle. We got the breakaway point and break-in point. So what will be the diameter? Here, from here to here, it is minus 11.48, and here to here 1.48. Both we will add. So it will be, diameter will be equal to 12.96. Is it correct?
Yes, sir.
1.48. This will be 12.96. What will be the radius? Radius will be equal to 6.48.
6.36.
Correct? It will be 4.96. Correct only?
Yes, sir. Sir, but
So
how can we know it is breakaway or breaking point?
see, between 1 and 2, 1 point should be there, and between minus 5 and infinity, 1 point will be there. So here pole are moving here. Okay. So if here it is going away, so it is a breakaway point, and 1.48 value will come here only. That is positive value. Again, these poles are moving here, entering into the real axis. Okay. So this will be the break-in point. Okay, after that one pole will go to this 0, and one will go tends toward infinity. Okay, because 1 0 will be at the infinity. Is it clear? Hello.
Yes, sir.
Okay.
Yes, sir.
Okay. So since radius is 6.48, how we can calculate the center? So in on this real axis, okay, somewhere center will be there. So this is minus 11.48. So what will be the radius? 6.48. So 11.48 minus 6.48, what will be this value? This is minus 5, comma 0. Is it correct?
Sir, yes, sir.
Okay. So center will be minus 5, comma 0 and the diameter will be 12.96. Is it clear to all up to now?
Sir, how center?
See, this real axis is a diameter, x-axis, this one. Okay. So somewhere center will be there on this axis only. How much distance will be there from center till the this point? That will be the radius. Okay. So since this point is minus 11.48, what should be the center? Minus 5. Then only minus 5 and minus 6.48. Then that will be minus 11.48. Is it clear?
Okay.
Okay. Okay. So the next question is, we have to calculate the gain at which the locus crosses 0.5 damping ratio. So this is open loop unity feedback transfer system or transfer system. So how we can calculate the zeta value of k at zeta is equal to 0.5. So simply we can write the closed loop transfer function. Okay. So 1 plus k into s plus 5. Okay, and this is s square minus 2s minus 3s plus 2. S square minus 3s plus 2 equal to 0. So it will be s square minus 3s plus ks plus 7 is equal to 0. Is it correct up to now? Just we have to find the value of k for which damping ratio will be equal to 0.5. Is it correct up to now or any changes is required? Okay, I think here I have done mistake. It will be 5k plus 7. 5 into k, it will be 5k and plus it will be 2, 5k plus 2. So I have calculated the characteristic equation from this open loop transfer function. This is a unity feedback transfer function. So what will be the omega n value? Omega n is equal to 5k plus 2. Is it correct? And
Yes, sir.
what
Yes, sir.
what will be 2 zeta omega n? So 2 zeta into omega n, that will be how much? This s is equal to k
Minus
minus 3. K minus 3 is there. So that will be k minus 3. Okay. So zeta value is how much? 0.5. Already it is given here. And that root locus is crossing 0.5 damping ratio line. Okay. It means zeta is equal to 0.5. So omega n will be equal to k minus 3. Okay. So it omega n here it will be 5k plus 2 under root equal to k minus 3 and it will be 5k plus 2 is equal to k minus 3 whole square. Okay. So the here we'll get one quadratic equation. Mm, from that we can solve the value of k. So 5k plus 2 is equal to k square minus 6s plus 9. Okay. So k square minus 11s, correct only, plus 7 is equal to 0. What will be the value of k? You can solve with calculator. 1 minus 11, 7. Much we are getting? 10.32 and other value is 0.67. Okay, is it correct up to now? 10.32 and 0.678.
yes, sir.
Out of this only one will be correct. Which should be the correct value and why? Can anyone tell? Which should be the correct value and why? Can anyone tell?
6.678 is the correct value, sir.
How?
And it falls under root locus, and 10.32 is out of root locus.
No, no, that is k value, not zeta value.
K value. Okay, sir. Okay.
K value. So this circle is there. Okay, if you see one circle is there. 1 second, I will draw that circle again. So one root locus is there where two poles are here at -1 and -2, or 1 and 2. Okay, 1 and 2. So from here one circle is there. Okay, it is entering here. Minus 11.48, 1.48. So some zeta will be there. Okay, zeta is equal to 0.5. So here we have to find k value. Somewhere it is cutting the root locus. Okay, so we have to find the k value. Is it correct? See, same value like zeta is equal to cos theta. Okay, so it can come in RHS also, right hand side also. So at one value at 0.678, okay, this root locus will be in right hand side. We have to verify this one. And if k will be equal to how much? 10.32, then root locus will be in the left hand side. Okay. See how it is, how we can just analyze it. Okay. These two poles are here. So somewhere I think in this zeta is equal to 0.5 line. I think we can extend like this one also. Zeta is equal to cos theta. Okay. Is it clear up to now? Like, see, two things are there. Just we have to discriminate at what value our root locus will comes in the right hand side. Okay, that will be unstable system. For a stable point, it will come in the left hand side. Okay. So one method I have told, like, let's say here it is there. So all multiplication from all the poles. Okay, these are poles. So we will see the distance is larger in this case. Okay, and if it will fall in this case, then from two poles, the distance will be lower only. Okay, so by visualization we can say that if that thing will fall in this side, okay, so multiplication of all the three distance will be less than 1. Just by analysis we can say. And if that point will fall here, okay, then this distance and this distance are higher. Okay, then multiplication in this case will be higher only. Is it clear? By observation we can say. Is it clear?
Sir,
Hello.
please explain once, sir.
See, K1 formula I have discussed. K is equal to multiplication from pole. All distance, there some, let's say this is some point. Okay. So up to this point, we'll measure distance from all the poles. So let's say these three poles are there. Okay. One it has one and one is. So this distance and this distance, three distance we are getting. So it will be higher only. If pole will be in this side, okay, no, that point where zeta will be equal to 0.5. Okay, so zeta is 0.5 means either it can be in left hand side or right hand side. So if it will be in right hand side, then distance from this two pole will be lesser only. Okay, and distance from this one pole. Okay, so in this case the k value will be lesser. Second case, when pole are in the right hand side. If it is in the left hand side, then multiplication of distance will be higher only. So higher we are getting 10.32 and lower this one. So this can be neglected just by observation. Is it clear?
Sir, but distance from that last pole to this point is much more, no, sir?
No,
Then
which one?
it will be also distance from these right hand side poles to this point is less, sir. But distance
But
from
only
left.
one, but two are lesser. But here two are higher, one is lesser.
Okay, sir. Okay, okay.
So indirectly we can say that this will be high. But other way also we can find exact value where it will be. We have to analyze in more detail. Okay.
Okay, sir. Okay.
It's just observation we can see that two value we are getting. One will cause in right hand side, one will in the left hand side. So this is in RHS because lower value K value, and this is in the LHS. So this will be the answer. Is it clear? Okay. Should I move to the next
Yes, sir.
question? Okay.
Yes, sir. Yes, sir. Okay.
So this question is given in terms of alpha. So normally we are varying the K value, okay? But here what we have to do, we have to vary the alpha and we have to find the center of asymptote, okay? So first we can write this equation like in terms of 1 plus gh, okay? So closed loop transfer function we can find, and characteristic equation we can find from that closed loop transfer function, and then we can write that in terms of 1 plus some gs, and alpha will be a constant output of that term, okay? So unity feedback transfer function is there. So what will be the characteristic equation for this one? So overall closed loop transfer function will be equal to g by 1 plus g, okay? So if you write the characteristic equation, that will be s square plus 3s plus 2, okay, this one term, plus alpha minus 1 s, okay, plus alpha minus 2 equal to 0. Is this the characteristic equation for this one? S square plus 3s plus 2 plus alpha minus 1s plus alpha minus 2, okay. Is it clear up to now? This is the characteristic equation,
Yes, sir. Yes, sir.
okay. So what will be the simplified version of this one? So there it is 3s and alpha minus 1s. So what we can write, s square plus 3 plus alpha minus 1 s. But we have to take all this in terms of alpha. Okay, something we have to write here. One second. Uh, how we can convert s square plus alpha minus 1. One second. S square plus s plus alpha s plus 1. Hmm. What we can write, 3 plus alpha minus 1 s, but alpha s will simply take outside, then it will be s square square plus 2 plus alpha into s plus alpha minus 2, okay. So if we'll take alpha common here, what will happen, s square plus 2s plus alpha s plus 1 minus 2 is equal to 0. Is it correct up to now?
Sir, this 2 will be cancelled
Okay, okay, where?
in third row S, in third
See,
line.
s square plus, one second, uh, s square plus 3 plus alpha minus 1 s, here 2 is there and last also 2 is there, na? And that will be cancelled, correct only. One second. So this will be our characteristic equation and we can write in 1 plus gs form again, okay. So we can write s square plus 2s plus alpha, s square plus 2s plus alpha into s plus 1 equal to 0. We can write 1 plus alpha s plus 1 divided by s square plus 2s, correct? So now this will be our g of s. We got in form of k into some transfer function. Okay, alpha into s plus 1 divided by s square plus 2s. So what will be our g of s here? Now our actual transfer function is, one second, it is 1 plus alpha into s plus 1 divided by s into s plus 2. This already I have written here. So what will be the root locus here? At 1 0 is there, at minus 2 is there. Okay, and 1 0 is at s is equal to minus 1. Is it correct? So what we have to find? We have to find the center of asymptotes. Okay, center of asymptotes will be a real pole. So minus 2 minus minus 1 divided by 2 minus 1. How much it will be? It will be minus 1. Is it correct? So center of asymptotes centroid will be minus 1. Here somewhere it will be. And number of asymptotes will be equal to 2. Pole minus 0. So at here it will be.
Sir, 1.
Uh, how? Okay, okay. It will be 1 only, no? One second, one second. Maybe I'm doing some mistake. Here, okay, okay. It's incorrect only. So centroid will be how much? 2. We have 2 poles and 1 0. So n is equal to 2 minus 1. That will be 1 only. So asymptote will not be here. But centroid, what it is asking? Center of asymptotes. So sigma real part of pole, so minus 2 minus real part of 0 minus minus 1 divided by number of pole minus number of 0. This is a minus 1. So at minus 1 only asymptote will be there. But if only 1 is there, then no need to think about the asymptote. And then our root locus will be like this one. It will come here and that will form a circle only. Is it correct? Is it clear up to now? So
Sir,
answer,
please explain, sir.
see,
Sir, previous slide, sir, previous slide.
okay.
Sir,
Hmm.
here instead of we have to combine s, then uh, uh, s into alpha plus 2 will come here, sir. Instead of that, we have taken alpha and s plus 1. Why like that, sir? This is
See,
quadratic equation, sir. S square plus 2s plus alpha plus 1. Instead of that, we have to take s square plus s into
which line can you first? Which
this
line?
line, sir, which you have, the line you have
Okay,
underlined.
s square plus 2s I
Yes,
have
sir.
taken here. Okay,
Okay, sir.
and alpha I have taken common. So this is alpha s, this is alpha. This is
What
s.
my question is, sir, we
Hmm.
have to take constants only at the last term
Okay, okay. So
in
here
this
we don't
quantity.
have any constant.
Sir,
See,
here
I
2s, sir.
which one? Which one is
Here,
constant? Alpha.
sir, first term is s square, okay, sir.
Huh,
Then second term should be s into alpha plus 2 should be there, sir. Instead of that,
huh.
you have taken 2s.
No, no.
Why you
This
have
is
taken?
s. S into 2 plus
Oh,
alpha.
okay, sir. That's okay, sir. Hmm.
Huh. After that,
But next line, you have taken s square plus 2s plus alpha into 2s plus 1 like that.
alpha
Why
into
you
s
have
plus
taken?
1. See, here 1, 2 was there, na? That I have not written here. So plus 2.
Okay, okay, okay.
One thing I have missed. See, directly I was writing s square plus 3 plus alpha minus 1s. Okay. Plus here it will be alpha only. This 2 and 2 will cancel. Okay.
Okay,
That
sir.
is
Okay.
0. Now it is clear?
Okay, sir. Now please, sir.
Okay, okay. So based on this, we can find the this one centroid. Okay. Should I move to the next question?
Yes, sir.
Okay. So this is last root locus question. After that, I will start the body plot. So this is a good question only. Like here we have to find the range of k or which the system is overdamped. Okay. So first we can draw the root locus. Okay. So at s is equal to 0, one pole is there. S is equal to minus 1, one pole is there, and s is equal to minus 2, one pole is there. Okay. So what is the overdamped system? It means where will be the pole in case of overdamp? Can anyone tell? Pole will be always on the left hand side real axis. Okay. For overdamped. Underdamped, it will be imaginary. Okay. Overdamped, it will be on real axis only. So number of asymptotes, how much? 3. Okay. So that 60, 180 angle will be there. And what is the centroid? So 2 minus 1 minus 3 minus 0 divided by 3 minus 0. Right only? So minus 1. So this is centroid. Okay. So from here it will come like this, and it will, the root locus will go like this. Okay. So at pole k is equal to 0 is there. Okay. So we are increasing the k till this point. Our system will be equal to, our system will be underdamped since both the poles are on the real axis. After this point, the system will become underdamped. So we can calculate k at this point. Let's say that is k1. So k should be greater than 0, less than k1 or overdamped. Is it correct? And k should be greater than k1 or underdamped. Is it correct? And k will be equal to k1 for critical damp. Is it clear to all? Otherwise, I will explain again.
Please explain this concept, sir.
See, if our poles are on the real axis, okay, at different place, in that case, system will be overdamped. This concept you know already.
Yes, sir. Yes, sir.
If it will be imaginary, then it will be underdamped. And if both
Okay.
pole will be at same place on the real axis, then it will be critically damped. Okay. So
Okay,
at
sir.
k is equal to 0, our root locus is starting from these two poles. It will move. Okay. At k is equal to k1, that is the breakaway point. Okay. So at k is equal to k1, these two poles are colliding together. So k is equal to k1. Okay. What will be the system? Critically damped. K greater than k1, it will be underdamped because poles are becoming imaginary. Okay. And k greater than 0, less than k1, it will be on the real axis. So it will be overdamped. Is it clear up to now?
Yes, sir. Yes, sir.
So how we can do? Just we can find the breakaway point. Okay. So breakaway point d by ds equal to 0. So d by ds 1 by s, s plus 1, s plus 2. S plus 1, s plus 2 is equal to 0. Okay. So d by ds, that is this value, s cube plus 3s square plus 2s is equal to 0. Okay. Now this will be top, it will be 0 minus 3s square, okay, and plus 6s plus 2 divided by this whole square, s cube plus 3s square plus 2s is equal to 0. Okay. So solution will be the breakaway point. So 3s square plus 6s, is it correct only? Uh, it will be plus or minus. Is it correct? Let's see one. S plus 1, s plus 2 only is there. So 3s square plus 6x plus 2. 3s square plus 6x plus 2. So what will be the solution for this one? This will be the breakaway point. Okay. All of you can also try this one. 3 6, 2. So one we are getting S is equal to minus 0.422, other we are getting minus 1.577. So it will be the correct breakaway point. See, minus 1.577 is not a correct because it is coming between minus 1 and 2. So minus 0.422 is the correct breakaway point. Okay. S is equal to minus 0.422. Is it clear up to now? So this point will be, at this pole will be minus 0.422. Okay. So K1 how we can calculate? Can anyone tell? Already I have told the formula. How we can calculate the K1 value? We know this pole here. Pole point we know. This point we know. Minus 0.422. So how we can calculate the K value here? Can anyone tell? What will be the K1 value at this point? This point is, breakaway point is S is equal to minus 0.422. Okay. So what will be the K point here? Can anyone tell? See, already I have told this formula. K is equal to product from all the poles divided by product from all the zeros. So this distance multiplied this distance and this distance. Okay. If no zero is be there, then that will be 1. So this distance is 0.422 into this distance is 1 minus 0.422 and the third one is 2 minus 0.422 divided by 1. So this will be our K1 value. Is it clear?
Yes, sir. Yes, sir.
So K1 we can calculate like this: 0.422 into 1 minus 0.422 into 2 minus 0.422 divided by 1. So this we are getting K1 is equal to 0.384. 0.384. Okay. So for over
What,
damped,
sir? The denominator one is what, sir?
1 is there. See, if no zero is there in the system, see
Okay, sir. Okay,
what we
okay.
are doing in numerator, we are at some point on the root locus, we are measuring distance from all the poles. Okay. Similarly, if any zero will be there in the system, in denominator, what we will multiply, will measure all the distance from the zeros to that point. Okay, where we have to measure the K value. And
Yes, sir.
that
Yes,
will
yes,
put
yes,
here. If
yes,
no zero is
yes,
there, that will be 1.
yes, 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 yes.
So what is the condition for overdamp now? K should be greater than 0, less than 0.384. Okay. In question, if it will be asked, what will be the maximum value of K for which our system will be under dam, over dam. So what will be the maximum value? This 0.384. Okay. At adject this value, okay, this will be little bit lesser than this. At adject this value, our system will be critically damped. And if K is greater than 0.384, then the system will be under damped. Is it clear?
So
Clear?
now the K value is 0.422
No,
and
no,
K1
not
is 0.8
not K value. Minus 0.422 is S value. S is equal to
S value,
minus
sir. Okay, sir. Okay, okay.
0.422. That is breakaway point. Okay, root.
Yes, sir. Yes, sir. Yes, yes,
But
sir.
K is 0.384 at this point. Where S is
Yes,
equal
sir.
to minus 0.422, there we have calculated the K that I am showing as K1, that is 0.384. Is it clear now?
Okay, sir. So then, how could we say that the it is over damped, sir?
See, overdamped means if both the poles will be on the real axis only. Okay.
Okay, sir. Okay, okay.
So here we are K is equal to 0, we are starting the root locus. See, at
Okay,
pole.
sir. Okay.
Again we are increasing the K. K 0 to infinity we are varying. Na? At K is equal to 0, it will start from pole. K is equal to infinity, it will go towards the 0. Okay. The
Yes,
poles,
yes, sir.
this is locus of the closed loop pole. It is moving. At some k1 value, both the poles are together on the real axis.
Yes,
Okay.
sir. Yes, sir. Yes, sir. Yes, sir.
So we can say that this is the maximum point at which the poles will be on the real axis. Okay. Is it clear?
Yes, sir.
Okay. Okay. So this is also one good way. Here also most of the students do the mistake. So I will just explain a good concept here. Like resonant peak, if something will come, so we have to solve the question like this. So one good conceptual question is here. First I will solve one question. Then next question I will ask you to solve. So this formula we have to remember for resonant peak. Okay. This is also a frequency response analysis chapter formula. So transfer function will be of this format. Okay. Then resonant frequency will be omega r is equal to omega n 1 minus 2 zeta square. And this is the important thing. MR will be k divided by 2 zeta 1 minus zeta square. Okay. So this thing we should remember. And bandwidth formula we have to also remember. If objective question will be framed, we can use this formula. Okay. So I'm going to show one question. And MR is given, resonant peak is given. So what will be the damping ratio? Okay. So MR formula we know, MR is equal to 1 upon 2 zeta 1 minus zeta square. This only. Here K is 1. See, if you see here, K is 1. So 1 by 2 zeta 1 minus zeta square is equal to 2.5. So what will be the zeta value? I am also calculating, you can also try. What will the zeta value here? Just we can solve this quadratic equation. So what is the value? We can just cross multiplication. So 1 by 4 zeta square is equal to 2.5 1 minus zeta square. Is it correct? Or we have done some mistake?
Sir.
Hmm. Any mistake is there?
A
2
2.5 square we have to do, sir. 2,
okay, okay.
six
2.5
point two.
square into 1 minus zeta square. It is correct, I think. So one second. What will be the equation now? So 1 by 4 into 2.5 square is equal to zeta square into 1 minus zeta. So zeta to the power 4 it will come. We have to solve this equation. So what will be this value? 1 by 4 into 2.5 square. 1 by 4 into 2.5 square. 0.04 we are getting. So 1 second. 0.04 is equal to zeta square minus zeta to the power 4. So zeta square we can count as x. So x square, okay, minus x plus 0.04 to 0. Is it correct up to now? Zeta square I'm assuming as x.
Yes, sir. Yes, sir. Correct,
Zeta
sir.
square is equal to x. Okay. So next equation we can solve. 1 minus 1 0.04. So 0.9581 value 0.0417 0.0417. Okay, is it clear up to now? So this just
Yes, sir.
x zeta will be under root 0.958 and other value will be 0.0417. So under root 0.958, 0.978. From here we are getting 0.978, and what will be this value? Under root 0.00417, 0.0645. So both will be the correct answer. One will be 0.978 either, or 0.0645. Is it clear? 0 0.0417. Okay, I have done some mistake. It will be 10 only. 0.204, 0.0417. This one you are getting. So 0.204. 1 second. These two are the correct option. 0.204. Is it clear to all? Should I show the next question? That is also based on this only.
Yes, sir. Yes, sir.
Okay. So this question I will give you just 2 minutes of time. Okay. Meanwhile, if you have any doubt, you can ask. If you are not getting how to solve it. So in this question, we have to find the resonant peak of the system. Okay. Already we know the formula. Formula I will show you once. This is the formula. MR is equal to K divided by 2 zeta 1 minus zeta square. Okay. You can note it also. K divided by 2 zeta 1 minus zeta square. Now this is our system. So we have to calculate the value of the resonant peak MR. If any doubt will be there, you can ask.
Sir, this is closed loop system or open loop?
You see, whatever is given here, this kind of second order system. Okay, under them. Closed loop only. See, this kind of system is given. Okay, closed loop transfer function. Then we have to find the resonant peak. So we know the formula for what? Second order system only. Okay. So what we can do here? What we can do here to make it to the second order system? Already I have taught one concept of insignificant pole. I think you remember.
Yes, sir.
So we have to use that concept, insignificant pole, and we can make it a second order transfer function. Then we can apply this formula. Where is that? 1 second. This one. So remember, mostly we are doing mistake. Here k is there. If k omega n square divided by this kind of function will be there, then mr will be k divided by 2 zeta 1 minus zeta square. Okay. So now you should solve it carefully. So what will be the first? You tell me what will be the simplified transfer function? What will be the transfer function after neglecting the insignificant pole? First you tell me. How we can find whether this is a insignificant pole or not? Anyone can reply. What is the concept behind that? Should I repeat that concept?
Yes, sir. Yes, sir.
Okay, I will repeat one. So see, we'll draw the locus kind of thing. So this is minus 10. Okay. And what will be the pole for this one? Minus 1 plus minus some complex will be there. No, not minus 1. What is the pole for this one? So S is equal to minus B plus minus B square minus 4AC. So minus 4 divided by 2. So that will be 1 minus 1 by 2 plus minus J root 3 by 2. This is for this one. Okay. So real part will be minus 1 by 2. Okay. What will be time constant for this one? That will be minus 1 upon real part of this pole. So time constant will be 2 for this one. For this one, what will be the time constant? 0.1. Okay. Minus 1 divided by this one. Minus 1 divided by this one. So this is dominant pole. So dominant pole by 5. How much we are getting? 0.4. Okay. So the concept is insignificant pole time constant should be less than equal to dominant pole time constant by 5. Okay. So this is dominant pole. This time constant I have divided by 5. So we are getting 0.4. And insignificant pole time constant is 0.1. So this is less than only 0.4. So this is insignificant pole. And this can be neglected. Okay. So what will be the simplified transfer function? Can anyone tell? After neglecting the pole?
Sir, point 1
Point
upon
1 upon
s square plus s plus 1.
correct one. So see, that concept only I was checking whether you remember or not. So every time if we are neglecting any pole or zero, that should be neglected in time constant form only. Okay. So this we have neglected in time constant form. So 1 plus 1 by 10 is. So 10 we have taken common, that will come in numerator. Now this is the transfer function. Now we have to calculate what will be the value of resonant peak. What will be the value? That formula already we know. So I am just also using that formula.
Sir,
And
we
all
have
of
to find zeta.
this, okay, zeta we can find from here. So what is zeta value? 2 zeta into omega n is equal to 1. Zeta will be 0.5, correct? From this one, correct only? Omega n is 1. 2 zeta omega n is 1. So zeta will be equal to 0.5. Now what will the MR value? I am also calculating, you also calculate. So 0.5 into 1 minus 0.5 square. How much you are getting? How much is the value? How much is the MR value? Anyone got?
Yes, sir.
How much?
0.115.
MR will be okay. So MR is equal to K divided by, okay, 2 zeta into 1 minus zeta square. So the mistake is normally we are neglecting this K value because some book formula is like that. This K will be not given omega n square. So directly it will be MR will be equal to 1 divided by 2 zeta 1 minus zeta square. So if we'll apply this formula, this will be wrong. Right? Okay. And second mistake is while converting into the this domain, we'll miss this one. Okay. So K value is 0.1 divided by 2 into 0.5 into 1 minus 0.5 square, which is equals to 0.1154. This is equal to 0.1154. Is it clear to all? Hello. Should I
Yes,
move
sir.
to should I move to the next question? Okay.
Sir, sir,
Yes, you can ask.
could you please explain bandwidth concept?
Bandwidth formula. Okay. Concept also I forgot. See, formula only I remember. Okay, I will just go through it once. Okay. This formula we got from this one. Okay, we have to just go through the theory once. Theory I forgot. I did. Maybe it will be there in my notes. So I will go through that and then I will just share and I will discuss. But if zeta value will be there and we have to calculate the bandwidth, then this formula we have to memorize. Okay.
Yes, sir.
Okay, I will just go through the notes. Then I will share the notes also and I will discuss that also. How this formula we got. Derivation, all derivation also I have. This all derivation I have. I will just go through that notes and I will say. Okay. But we have to remember this formula because for objective question, this we should memorize. Okay. So now I am showing just some basic Bode plot formula. Okay. After that, I will solve some variety of questions based on the Bode plot. So Bode plot just we are drawing between the gain and frequency in logarithmic scale, and angle also angle of a system g of j omega. Okay, that will be the open loop transfer function, like plant transfer function, like this one g of j omega, like this is there. So for this one we are drawing the Bode plot. Okay, so to design the controller we are doing this to make the overall closed loop transfer function stable. We are doing this analysis. So some rules are there. Gain crossover frequency. So frequency has which the magnitude line will be crossing 0 dB. I think all of you know already there in the video lectures, but just I am revising. So omega phase crossover frequency at which the phase plot is crossing minus 180 degree. Okay, and this is phase margin formula 180 degree plus phase angle at omega gc at gain crossover frequency, and gain margin formula is, so linear formula, what is the gain margin? Linear scale, gain margin will be 1 divided by magnitude of the system of plant function at omega phase crossover frequency. Okay, and gain margin will be equal to minus, so if it will convert into this one, so 20 log 1 by gm omega pc. It will be equal to, if it will go at top, it will be equal to minus. So minus 20 log g j omega t. I think this formula all of you know. So just I have revised it. Okay. Now this is very good trick. Like if we want to convert any given Bode plot, any given Bode plot will be there. Okay. And we want to convert the transfer function, Bode plot to transfer function. So some corner frequency will be there. Okay. So like this we can write K, let's say here it is starting. So K starting minus 20 dB per decade means K by S. So first I am writing K by S. Again at A, 10 is there. So 1 plus S by A. Again at B, 10 is there because it is going plus 20. So 1 plus S by B. And divided by at C, it is directly going from plus 20 to minus 20. So here it will be a square. Okay. So this will be the transfer function, and this is the rule, very important rule, how we can calculate the value of K. Okay. So while calculating the value of K, the corner frequency greater than omega. So at this omega we know the magnitude. Okay. So all the corner frequency greater than the omega at which the magnitude is known is neglected. So some in Bode plot, some magnitude value will be given at some particular frequency. So while calculating the K value, we'll neglect all the corner frequency which are greater than omega. So this, if you solve some question, then it will be more clear. Is it clear, this concept? Should I repeat it again, or I should go to the questions? Hello?
Sir, we should go.
Okay, okay, okay. So this is also same concept, just if this kind of line will be given, okay, initially only minus 20 n dB per decade, and this is crossing at omega. So here K will be equal to omega to the power n. Directly, if this kind of line will be there, directly we can calculate K value. But if you see the basic also, and the transfer function will be equal to K divided by S to the power n. Then only we will get minus 20 n dB per decade. Okay. So we know the magnitude at omega. So here after omega no corner frequency is there. So 20 log k minus 20 n log omega is equal to 0, because at omega, what is the magnitude for this one? At omega is equal to 0. Okay. So what is the k value? K by log k is equal to n log omega, and that will be log omega to the power n, and k will be equal to omega to the power n. So directly we can find for this kind of system, if it is crossing, and here at omega we know that the magnitude is 0 and minus 20 n dB per decade is there. So k will be equal to omega to the power n. And similarly, if this kind of system will be there, okay, so k will be omega to the power minus n. Is it clear? Hello? Is this clear, or I should explain again? Can anyone reply?
Yes, sir, it is clear.
Okay, okay. So just I will solve the questions one by one. Whatever the method I have told there, that only I am going to use. Okay. So these are, I think, previous year gate questions only. Already Bode plot is given. Okay. So we will follow the same steps what I have told earlier. And where the magnitude is known here. See, magnitude is known at omega is equal to 0.1. Okay. So while calculation of the k value, see, some options will be same, but k value will be different. The main thing is calculation of the k value. So while calculation of k value, we will neglect all the value of corner frequency which is greater than 0.1, because at 0.1 we know the magnitude value. So we'll write one by one. K transfer function will be equal to k divided by, so initial how much? Minus 40. So it should be s square, correct only. Again at 2. At 2 again it is going minus 60. So 1 plus s by 2, correct. And again here it is going minus 40. So at 5.0 is there 1 plus s by 5. Okay. And again at 25 one pole is there. So 1 plus s by 25. Is it clear up to now? How I have done?
Please explain, sir, once.
See, already I have discussed one formula here, how we can know. So minus 20 means a starting one pole is there. So K constant will take by S. Okay. Again at A, what is happening? This is becoming 0. 0 means we are adding a, this slope is constant means plus 20 we are adding. So at A we are adding a 0. Okay. Again at B it is going plus 20. Plus 20 means again a 0. 1 plus S by B. At C directly plus 20 to minus 20. It means minus 48 is coming. So C two poles are there. Okay. Similar kind of observation we can do here. K starting slope is minus 40. Minus 40 means two poles are there. So K by S square. Again first corner frequency 2. After 2 we are getting minus 60. So 40 minus 20 minus 60. That means at 2 we are adding one pole. Okay. Again at 5, after 5 it is becoming minus 40. It means 1 0 is adding. So 1 plus s by 5. Again at 25 it is going minus 60. So 1 plus s by 25. Is it clear?
Yes, sir, now cool, clear.
Okay. So see, so all the how we can calculate the magnitude at 0 omega is equal to 0 0.1. Omega is equal to 0 0.1. Magnitude is 80 dB. Okay. So out of these two, okay, one option will be correct, because s plus 5 s square, in this we are not getting s square, but k value we have to calculate correctly. Okay. So first I am going to simplify this. So it will be k into s plus 5. Okay. And the remaining things will be, so, so first we'll calculate the k value, then we'll do the simplification. So 20 log k, okay, minus 40 log omega is equal to 0 0.1. 0 0.1 is equal to 80. This equation is clear to all? 20 log k minus this value. Because for calculation of k, all the corner frequency which are greater than equal to 0 0.1, I am neglecting. Okay. So s is equal to s only means 0. 1 plus s by this is there. So corner frequency is 2. So all parts I am neglecting while calculating the k value. Okay. Because at omega is equal to 0 0.1 we know the magnitude. So while calculating the magnitude, we'll neglect all the corner frequency which are greater than 0 0.1. So 20 log k minus 40 log, because s square. So minus 40 log omega is equal to 0 0.1. We are getting the magnitude as 80 dB. Is it clear, this equation? For
Please
calculation of
once.
k. See, one rule I have told, like let's
Yes,
say
sir.
in this one is magnitude is known at 0.1. Let's say we know the magnitude at 0.2. Here if magnitude will be known, let's say here one line will be there and magnitude will be known here. Let's say some 70 dB. Okay. In that case, what we will do, all the corner which are uh, one second greater than equal this you know mm, corner frequency which are greater than equal to omega as sweet magnitude is known should be neglected. Okay, so that will be neglected. So if it will be 2 also, then also will be neglected. If it we will get at 5, then this 2 should be considered. Okay, if I got any magnitude value at 5, okay, so corner frequency greater than equal to 5 should be neglected while calculating the magnitude. So then these 2 will be neglected, but 20 log k minus 40 log omega minus 20 log, this will be s plus 1 plus s by 2. Na? So this will be some magnitude. Then we have to consider this one also. Okay, but here we know the magnitude at 0.1. So all the corner frequency which are greater than 0.1, we will neglect. So what will be the remaining? K by s square. Okay, after neglecting k by s. So 0.1, what will be the magnitude? The magnitude will be k by omega, so 0.1 square. Okay, so if we will convert into dB, so 20 log k minus 40 log omega. This will be the magnitude at 0.1. For this one, if we'll convert into the dB value, so we have to multiply with 20 log. Okay. So log A by B means log A minus log B. And that will be omega square. So omega square will come outside. So 20 log K minus 40 log omega. So at 0.1, what will be the magnitude? It should be 80 dB. So that's what I have written here. 20 log k minus 40 log 0.1. This should be equal to 80 dB. Is it clear? Hello?
Yes, sir. Yes, sir.
Okay. So from this equation, we can calculate the value of the k. Okay. So now what is the value of k from this equation? You can just use calculator and tell me. So log 0.1. Log 0.1 how much? Minus 1. So log 0.1 is minus 1. So 80 minus 40, 40. 20 log k is equal to 20
Sir,
log
I am
k.
getting C.
You are getting C. How? See, S square should be there, na? But in C, S square is not there.
Yes, sir. B,
So,
B, B.
B should be the correct option. Okay. So, 20 log k is equal to 40. Correct only? And log k will be equal to how much? 2. So, k will be equal to how much here? 100. Okay. But see, it is not the actual k. Now, I am simplifying this equation. So, k into s plus 5 divided by s plus 2 and s plus 25. Okay. So 25 into 250. Okay. So 50 by 5. Is it correct? S square here. This 25 into 250 will go in numerator and this 5 will come in denominator. So this will be 10 extra is there. Okay. So 10 extra into 100. So that will be 1000 s plus 5 divided by s square into s plus 2 into s plus 25. So option B is the correct option. Is it clear to all? Hello. If anyone have doubt, you can ask.
Yes, sir.
Okay. Okay. So similar kind of 2-3 questions I have taken. All are previous year only. So okay. This question is little bit different. So just I am solving it. One system is given GFS. So GFS is equal to e to the power minus 0.1 s divided by s. Okay. And the gain margin of the system we have to calculate. So gain margin is equal to minus 20 log Gj omega at omega p, phase crossover frequency. So what is phase crossover frequency? Where the angle Gj omega will equal to minus 180 degree. So that some omega value will get, that will be equal to phase crossover frequency. Okay. So here what will be the angle? E to the power something is there. So angle will be minus 0.1 into omega. So this will be in radian. How we can calculate, convert into degree? Uh, pi radian 180 degree. Okay. 1 radian 180 by. So 180 by pi we can multiply. So this angle. This S angle is minus 90. This total angle should be equal to minus 180 degree. So from here, if we get the value of omega, that omega will be equal to our phase crossover frequency. Okay. So minus minus will cancel and it will be 90 here. So 0.1 omega by pi, okay, is equal to this 90 by 180. So 1 by 2. Okay. And here it will be 10 by 2, 5. So omega will equal to 5 pi. This is phase crossover frequency, where our system angle will be equal to minus 180 degree. So I have equated the angle equal to minus whatever the omega value will get, that is the phase crossover frequency. Is it clear up to now? Hello? The phase crossover frequency means the angle of the system should be equal to minus 180 degree. This numerator is there, e to the power minus 0. If we put omega, e to the power minus 0.1 omega. This angle is in radian. So minus 0.1 omega into 180 by pi, this angle, and this S is in denominator. So that angle will be j omega, that will be minus 90. This should be equal to minus 180. By solving this equation, we got the phase crossover frequency as 5 pi radian. Is it clear to all up to now? Hello?
Yes, sir.
Okay, okay. So, what is the gain margin? Gain margin will be equal to minus 20 log Gj omega, okay, magnitude at omega pc. Okay, so minus 20 into log, what is the magnitude of this system? 1 by omega. This exponential magnitude is 1 and 1 by j omega. So magnitude will be 1 by omega, correct? But it is 5 pi. So it will be, gain margin will be equal to minus 20 log 5 pi. Is it correct? No, no, 1 by 5 pi. So omega is 5 pi, that will be 1 by 5 pi. How much we are getting? To log 1 upon 5 into pi. 23.92 we are getting. 23.92 dB. Is it clear to all? This will be the correct option. Anyone have doubt, you can ask. Otherwise, you can move to the next question. Hello.
Okay, sir.
Okay, okay, okay. I'm just moving to the next question. Okay. So this is also one Bode plot is given, get previous year question. So already this kind of formula I have explained how we are doing. So we'll see one by one. So a starting is K divided by S. A starting is a minus 6 dB per octave. Okay, is equal to minus 20 dB per decade. Okay. So we'll see one by one. So K by S, K divided by S is there. K by S. Okay. After that, this 2 is coming. At 210 is coming. So 1 plus S by 2. Okay. Again at 410 is coming. So 1 plus S by 4. Correct. Again at 8, what is there? One pole is coming. So 1 plus S by 8. Okay. Again at 24, one pole is coming. So 1 plus S by 24, and at 36 also one pole is coming. So 1 plus S by 36. This formula only I have told. Okay. So this is the transfer function. Okay. Is it clear up to now how I have written this? If any doubt will be there, I
Sir,
will.
sir,
Okay.
once again explain, sir, how can you write a transfer function from both plots?
See, I will just explain the rule first, and initial only I have told. So this is the rule. Okay. If any transfer function will be given, okay, we'll see the starting slope. So starting is minus 20 dB per decade. So I will just write a step one. I will write k. Okay. Minus 20 dB means one one pole will be at 0, starting only. Okay, again at A, the slope is becoming 0 dB per decade. Okay, so 0 means minus 20 plus 20. It means we are adding a 0 here. So at A, we are adding a 0. So 1 plus S by A. Okay, again at B, it is becoming from 0 dB to plus 20 dB. So plus 20 means again we are adding a 0 here. So 1 plus S by A, 1 plus S by B, and at this C point it is becoming minus 20. So from plus 20 to minus 20, it means minus 40 we are adding, and minus 40 means 2 pole we are adding at C. Okay. So this is the initial transfer function. Okay. We can write after that, we can find the value of K. So how we can find the value of K? So for calculation of K, corner frequency which are greater than equal to omega, at which the magnitude is known, it should be neglected. Okay. So this is one rule for calculation of K value. So this is clear how I have written this here. So in this
Yes,
third,
sir.
so same thing I have applied here. See, same thing I have applied here. Initial slope is minus 6 dB per octave. It means 20 dB per decade. They have written here. Okay. So K here, starting S I have written here. Okay. Again at 2, it is becoming minus 20 to 0. It means we are adding a 0 at 2. Okay. So K into 1 plus S by 2. Again, what is happening? At 4, we are adding another 0. So 0 to plus 20. So 1 plus S by 4. Okay. After here, at 8, it is becoming plus 20 to 0. So plus 20 to 0 means what? It means we are adding a pole here. Okay. So 1 plus S by 8. Again, it is going up till here. At 24, we are again adding a pole because 0 to minus 20. So 1 plus S by 24. And here it is again minus 6 to minus 12 means one pole we are adding at 36. So 1 plus S by 8, 1 plus S by 24, 1 plus S by 36. Is it clear?
Yes, sir.
Okay. So see, one formula also I have told, K is if any line is there and it is crossing some value, okay, a straight line. So K will be equal to omega to the power n. Okay. If the it is a straight line is there. So here omega is equal to 8. So how we can find the K value? K is equal to omega is what? 8, and this is minus 20. Okay. So 8 to the power 1. See, this derivation already I have done here. So if this kind of a starting will come, a starting slope, and we know the where it will cross. Okay, if we will draw like this, so in that case directly we can find the K value, and K will be equal to omega to the power n. So 8 to the power 1, that will be 8. Okay, so it is asking A by B into K. So K we know, K is equal to 8. What is the A value? A is equal to 1 by 4 here. Okay. And B is 1 by 24. So 1 by 4 divided by 1 by 24 into what? 8. Correct only? So 1 by 4 by 1 by 3, that will be equal to 3 by 4. So this value will be equal to 3 by 4. How much if we will simplify it? So 3 by 4 will be equal to 0.75. This is the fill in the blanks type question. Is it clear?
Yes,
Yes,
sir.
sir.
Okay. So based on this only, this is a body plot question. Also, we will solve on the same basis. So starting, if you'll see, okay, from this body plot, where the magnitude is known, can any of you tell where we know the magnitude of the system? Initial magnitude is not known, but magnitude is known at 0.5. Okay, and here we don't know what will be the value here and here. Okay, so how we can calculate this value? See, this is there. So here 12 dB. This straight line is 12 dB, and this is how much? 0. So omega 2 we can calculate. This is omega 1, and this is, let's say, omega 2. Okay, so 20 dB per decade. Okay, this should be equal to y2 minus y1 divided by x2 minus x1. So y2 is how much? 12 dB. So 12 minus 0 divided by log omega 1 minus how much? Log 0.5. Is it correct? For this line I am writing the slope. So this point I know 12 dB, this point is 0 dB. So 12 minus 0 divided by log, this is logarithmic scale. Okay, so log omega 1 minus log 0.5. So from here we can calculate the value of log omega 1 we can calculate. What will be the value? Omega 1 I am also calculating. So log omega 1 minus okay, log 0.5, 12 by 20. Okay, so 12 by 20 plus 0.5, 12 by 20 plus log 0.5. How much we are getting? Log omega 1 is equal to 0.2989. And if it will do 10 to the power, so 10 to the power 0.2989. So we are getting 2. Omega 1 is equal to 2. Is it clear? Omega 1 I have calculated from this slope, because we don't know this corner frequency. So from this data we have to calculate. Omega 1 I have calculated as 2. Similarly, this one we can apply here. So minus 40, this should be equal to 0 minus 12. So this y2 minus y1, 0 minus 12 divided by log 8 minus log omega 2. This calculation is clear to all? First one, omega 1 value. Hello?
Yes, sir. Yes, sir.
Okay. So similarly, from this one, we can calculate the omega 2 value. So that will be log 8 minus log omega 2 is equal to 12 by 40. Okay. So log omega 2 is equal to log 8 minus 12 by 40. Okay. So log 8 minus 12 by 40. How much we are getting? 0.603. Okay. So 10 to the power 0.603. We are getting as 4. So omega 2 will be equal to 4. Okay. Now we got the value. This is 2 and this is 4. We can write the transfer function. K initial slope is how much? 20. So K into S divided by, here 1 0 we are adding. So 1 plus S by 2. Again here we are adding how much? So 2. So 1 plus S by 4 whole square. This will be the form. Is it clear? Hello?
Sir, to find the second value of omega 2, we have taken
Okay.
minus 40 equals to 0 minus 12.
See, so y2 minus y1. This is y2 0. or y1 12. So y2 minus y1, 0 minus 12 divided by x2 minus log 8 minus log omega 2. This should be equal to minus 40. Here I am going in this way. So y2 is 12, y1 is 0. That slope of a straight line. Okay. x1 y1, x2 y2. Is it clear?
Yes, sir.
Oh, okay. So transfer function will be of this form. This will be our transfer function. Is it clear? So if you see the option, which is the correct option? This is not the correct option. When a square is required. So 1 plus 0.25 and 1 plus 0.5 s, 1 plus 0.25 s whole square.
A is correct.
A is correct. But how here it is 2. Let's say two options are given. One options will be given like 4s divided by 1 plus 0.5s into 1 plus 0.25. So we have to calculate the k value also. Okay. So what is the k value? How we can calculate? We know the magnitude at 0.5. At 0.5, what is the magnitude? 0 degree. Okay. So omega is equal to 0.5. Magnitude is known, which is equal to, and also, other one method also I told, k is equal to omega to the power minus 1. This is 20 dB per decade. So here I have wrote one direct formula. See, if this kind of system will be there and 20 n dB per decade will be there, so k will be equal to omega to the power minus n, and this kind of k omega to the power n. So here directly you can find the k value. K is equal to omega to the power minus 1, and what is omega? 0.5. So 0.5 to the power minus 1, what it will be? 1 by 0.5, that will be equal to 2. So what is the k value? 2. Is it clear?
Clear, sir.
Okay. Okay. So some get 2024 question also I have given. See, these are easy question only. So just explain this. This is 2 marks question, and this is also 2 marks question. So I'll explain one by one. So a stable closed loop system is shown here in the figure, and the magnitude and phase value of the frequency response are given in the table. Okay. So at some particular omega value, magnitude and frequency is given, magnitude and phase is given, and we have to calculate the value of gain k. So here one system is there. This is GS. Whatever the data given here, that is for GS. Okay. And we have to calculate the value of k greater than 0 for 50 degree phase margin. Okay. So what is phase margin? Phase margin is equal to 180 plus Gj omega at omega Gc. Okay. So 50 degree phase margin means our total angle should be how much? Our total angle should be how much? So 180 plus something is equal to 50. So what will be the x value? X should be equal to how much? Minus 130. Is it correct?
Yes, sir.
Okay. So this total system angle should be equal to minus 130. Okay. So this how much will this portion, how much angle will contribute? Something by j omega. So minus 90. This is giving minus 90. So what should be the angle of this one? See, for 50 degree of phase margin, okay, we need the total angle contribution by the system. That should be equal to how much? Minus 130 degree. Okay. Out of minus 130 degree, this first part is contributing how much? Minus 90. Is it correct? See, something by S. K by S into GS. This is our total plant. Okay. So total angle required is minus 130. Then only will, if we'll add 180 minus 130, we'll get 50 degree phase margin. Is it clear up to now?
Yes, sir.
Okay. So this how much angle it will k by s means s is equal to j omega. It will contribute a angle of minus 90 degree. So what should be the angle contribution of this one? GS. So minus 90 minus 40. How much it will be? Minus 90 minus 40. It should be equal to minus 130. Correct. So which part we should select from this one? This will be the right path. Is it clear? See, at some particular value, if the angle will be minus 40 degree, okay, this angle, then only we will get the a phase margin of 50 degree. And now we have to make the value k such that the gain will cross 0 dB at this frequency. Is it clear? Should I explain again? Hello.
Clear, sir.
Okay, okay. So see, we got the angle. Okay. So what our aim is at this frequency. This frequency we have to make omega gc gain crossover frequency. Then only this will be the phase margin. Okay. So if we'll make this gain crossover frequency means at this particular frequency, our system magnitude should be equal to what? Total magnitude should be equal to 0. Okay. So what should be the value of k? We have to calculate. So already this g magnitude is equal to minus 7. So what magnitude should be contributed by this? That if it will contribute plus 7, then overall magnitude will be equal to 0. Okay. So we can write like this: 20 log k minus 20 log 0.5. This should be equal to 7. Then only what will happen if we are doing like this, then this value will contribute a magnitude of plus 7 such that at 0.5 what will happen, this will become a omega gc. What is omega gc? At omega gc the overall system gain should be equal to 0 dB. Okay, but this alone was contributing minus 7. So how much should be contributed by this one? This should contribute plus 7. So 20 log k minus 20 log 0.5, this should be equal to plus 7. Is it clear? So from this one, we can calculate the k value. Is it clear up to now? So it will be 7 plus 20 log 0.5, 7 plus 20 into log 0.5. How much? 0.979. Is it clear up to now? So from here we can find the value of k. Is it clear? What will be the k value? Can you calculate? Hello, am I audible? Okay. So just I am calculating the k value. 1 second. 20 log k minus 20 log into 0.5, okay, is equal to 7. So 7 plus 20 log 0.5 equal to 0.979. So this value will be 0.979 and 20 log ki is equal to 0.979. Okay, so 0.9794 it will be, and 0.9794 by 20, so ki will be equal to 10 to the power 0.9794 by 20, 10 to the power 0.9794 by 20, 1.119. Is it correct? K value I am getting as 1.119. Is it clear? Hello. If any other doubt is there, you can ask. Am I audible? Hello? So if no doubt is there, we can close the session. Can anyone reply? Hello? Am I audible? Hello?
Yes, sir. Audible, sir.
Okay, okay. So the final answer is 1.119. This is the 2 marks question, get previous year. So if any other doubts will be there, you can ask. Otherwise, we can close the session. Any other doubts are there like, related to today's session? Anything otherwise, any other thing if you have doubt related to any previous session also, or any questions you are facing difficulty to solve, you can ask me. Any doubt is there? Hello. Should we close the session?
Yes, sir.
Okay. Okay. So thank you all. We'll meet
Thank you,
on
sir. Thank you.
next Sunday. Okay. Thank you.
Thank you, sir.